hyperspace travel. Will we be able to overcome the speed of light? Humanity has always strived to travel faster, overcoming the limitations of physics and space. However, one of the biggest obstacles to interstellar travel is the speed of light, which is approximately 299,792 kilometers per second. According to current thinking, this is the maximum speed at which anything in the universe can move. But are we really limited by this barrier, or are there ways to get around it? The idea of hyperspace travel has gained popularity not only in science fiction, but also in serious scientific theories. Scientists are considering the possibility of curving space-time, which would allow them to circumvent the speed limit. One of the most promising concepts is the so-called curved engine by Alcubierre. His idea is that the spacecraft does not move through space, but spacetime itself is compressed in front of it and expanded behind it. This would make it possible to move at any speed without violating Einstein's theory of relativity. However, the realization of such a technology would require an exotic substance with negative energy, which has not yet been discovered. Some physicists suggest that such matter may exist in certain quantum states or in vacuum fluctuations, but its production and use remains a mystery. Another possibility for overcoming the speed of light is the use of so-called wormholes, hypothetical tunnels in space-time that could connect distant points in the universe. If such wormholes do exist and can be stabilized, they would allow instantaneous travel between star systems. However, like the curved engine, this method requires the use of exotic matter. Beyond the theoretical models, the question remains of how such travel would affect the traveler. The theory of relativity predicts that when approaching the speed of light, the time stream slows down. This means that for those traveling at high speeds, time will pass much more slowly than for those who remain on Earth. This can create the effect of a space traveler returning after his expedition and seeing that tens or even hundreds of years have passed on his home planet. Another important aspect is energy consumption. According to current estimates, the Alcubierre curve engine requires energy equivalent to the mass of the planet Jupiter. This makes the technology completely unattainable with the current level of knowledge and technology. Some scientists suggest that more efficient ways of deforming spacetime can be found, but so far these are just hypotheses. In addition to wormholes and curved engines, there is another concept that can bring us closer to hyperspace travel: the use of so-called quantum teleportation. In quantum mechanics, there is a phenomenon called quantum entanglement. This means that two particles can be instantly connected to each other, regardless of the distance between them. If we could scale this effect to macro objects, it could open up a new way of traveling, where information about the physical state of a person or object would be transmitted instantly, and the object itself would be recreated in another place. However, quantum teleportation faces the problem of destroying the original. Since teleportation involves the transfer of information, not a physical object, the question arises: will the teleported object be the same person as the original, or will it be just a copy of it? This is one of the main ethical dilemmas of this approach. Another possibility is the manipulation of dark matter and dark energy. Dark energy is believed to be responsible for the expansion of the universe. If we could understand the mechanisms of its work and learn how to control this process, it could be the key to creating a new generation of interstellar engines. Despite all the theoretical possibilities, we do not yet have any practical way to realize hyperspace travel. However, humanity continues to explore, and with each discovery, we are getting closer to being able to overcome interstellar distances. As history shows, many technologies that once seemed like science fiction later became reality. Perhaps hyperspace travel will have the same fate. So, although the idea of hyperspace travel seems fantastic, it has a basis in modern physics. If mankind can find a way to bend space-time or stabilize wormholes, then traveling between the stars could become a reality. So far, none of these theories has been confirmed in practice, but scientific research is ongoing, and perhaps in the future, we will be able to break the barrier of the speed of light, opening a new era of interstellar travel. Translated with deepl.com, free version,